Okay, so this like it's like the cooling fan of microwave, right? So it sucks in air and then exits it. So my idea is like suck up some of the air from the some of those particles from the environment and then shoot it outside. So I'll just put it in configuration here like that. I just hope I have more circuits. Okay, I think that I don't know. Oh, it's fine now. Okay, so we just power it. These are the input terminals. So I have some spare wires. Let's see what we have. Okay, so I have these others. Okay, so like that. Okay, this is mess up everywhere. The light, I don't know if it's easy counteracting the. Okay, it's done. Let's see if it's doing any good. Okay, it's picking up some, yeah. Yeah, it's definitely working. The particles are really light, so yeah. So maybe you can see. Yeah, it's not that powerful, but at least doing something. Wow. Wow, this crazy one just fits perfectly, like, oh. Like this is one thing to see what we have. Wow. Okay. So we don't have this thin piece here. Like so we round it a hole up here. This is like the suction is the input to this guy. So it has to be like the same diameter with this guy. So we'll use this like this drill as a lead. We also cut the hole, but we have to just do some measurements. We have to measure the diameter of this hole. So take on my ruler. I don't even have to take it. Let's see what we have. Like 3.5 centimeters. 3.5 centimeters divided by 2, 1.5 divided by 2. That's 2 point. If I divide by 2 is what do you have? You have 0.5. Wait, you have 3.5, right? 3.3 divided by 2 is 1.5, and now you have 5 millimeters divided by 2, you have 2.5 millimeters, so we have 1.75 millimeters. That makes sense, 1.75 millimeters. So we draw a line, we mark a point 1.7 millimeters away from the center of this where this bolt is, and then you place a sharp object there, and then as you rotate, you just keep the sharp object at that point until it digs in, until it cuts out. So let's quickly do that. Let's mark the point. Let's tighten our bolt first. But I'm still finding a way. I'm still trying to think of how we make this like solid because now it's really soft, so I have to prevent this body from touching or getting in contact with this. Yeah. Somewhere. Okay, this is it. This, so this is it. Okay, so from the book, let's see what the dimensions are. So the radius is 7.5 centimeters. So that means the wow. So that's what I'm looking for. So just get there. So wow, that's a good seal. Like, see what I'm talking about? Are you seeing what I'm talking about? Are you seeing? Actually, so you see, that's the idea. But now we need to create now vent through which the air that's stuck from the front will be shot. Yeah. So that's an extra thing. And then we have to reinforce the we have to like place some wood blocks in between it, which seems we need to screw it in place. We need to bolt these two pieces in place. But now the problem is I don't know. But these are so cool. It's cool. Wow. I didn't know this was. But I'm going to try this out on Facebook. Luckily for us, the blender has like a sort of like speed control now. So I haven't actually disassembled the blender completely. We still have access to like the potentiometer. I'm sure it's using like a triac to control the. Since so cool, then this is probably right. I'm sure it's using like a triac because from the second board I found it has like a potentiometer. So I think it's using like a triac. And then the potentiometer is varying the voltage that is being applied to the base of the triac. Thus varying the voltage. So it's now time to clean up the mess we've made. I think that's all. So let's speed our guide. Let's see on the screen. It's fun. That's like this whoosh. Okay, so let's clean up this noise maker for that. Something.
That's my bicycle. That's the other. You are here. That's fine. Let's look at
Yep, well, they can go is good now. So the next step is actually find a way to okay. So the next step is to find a way to mount this to this. So the idea is to use this wood, right, and then the four corners are actually marked. We simply just cut grooves and then insert it into the four corners, and then using that block will act like a mounting point for screws that will actually raise some holes here to hold it in place. So let's quickly move on to that by first measuring this dimension, the distance, and then cutting the wood, and then yeah, let's move on to that. Blocks that will be set on the various corners, right? Like the various corners. So now we have to actually cut these sections to give way for this man to actually fit inside. So let's do some measurement and do that. For the cross section area, let's see. Okay. That's like 1.4. Okay. The first thing is actually 4. This line. Like that. All the corners. So now I have the four corners marked, right? So we have to simply just cut is it 1.4 centimeters wide grooves like down to these blocks are fitting. Is it 1.4 centimeters wide grooves like down to these blocks are fitting. Is it 1.4 centimeters wide grooves like down to these blocks are fitting. Okay, we are done fitting the four blocks or wood blocks. So the next thing is to actually glue them in place. But here's the problem. I actually created a larger hole than the next person. So already now actually fill these gaps. But anyways, let's just let's check if they are aligned and then do some slight adjustment and then glue it in place. But anyways, let's check if they are aligned and then do some slight adjustment and then let's see if it turns. Okay, it turns freely. It's not actually level. So let's have to stand it. But here's the thing. We don't actually need FX here since the air is going to be existing out of here anyway. So I guess we just glue it in place and then drill the holes. Okay, so we let the glue. Okay, so we let the glue set. Okay, so we let the glue set, even though that wasn't necessary and it's already dark. But now we have our 4 screws and what's left to do? Oh, okay. Okay, so we let the glue set, even though that wasn't necessary and it's already dark. But now we have our 4 screws. So the next thing to do is actually to drill the 4 holes beneath this. But so one thing I often like doing is when drilling plywood, I often apply like some super glue to that part to prevent from scattering on the way plywood or thin brush. So so I already marked like the 4 different spots. So that part is just scattering on the way plywood or thin brush. So I already marked like the 4 different spots. So I'll just stand. So I guess I'll just drill anyway around that point. So this is not right. It's not right. Opposite. 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 We have lost it like 45. Measures. So that's like that's about 0.5 centimeters. So we'll just take. I mean, it's about 1 centimeter. So we'll just take 0.5 centimeters from the perimeter. So we are approximately around the center when we're about 0.5 centimeters. I mean, it's about 1 centimeter from the perimeter. So just use this kind of yeah, approximately around the center when we're about 0.5 centimeters. Okay, that's next. This one is a bit funny. Okay, so now we apply spaghetti on each of those mark points. Now we apply spaghetti on each of those mark points. So you now have to drill. Yeah, I often break these things since I'm very fragile, I'm very small. So you now have to drill. Yeah, I often break these things since I'm very fragile, I'm very small. It's connected. Let me lock it. Okay, so we simply just held it in. Okay, so we just okay, so we simply so we simply just held it in place with just 2 screws. The other screws I have really large, and I'm afraid they are going to maybe break the wooden blocks, but well, so all that's left to do is to cut some these slots here for the exhaust or exit air to rush out, and then put in somehow there's some sort of inlet to suck in the air for testing. Let's see if it actually works. But I guess we can actually test now. I'm confused. Okay, so what we'll do now is we'll just cut some stuff here. So that's really simple. So what we do is simply just put that there, and then like a pen. I'm done with the drill. that's fine. So, okay, so what we need is to cut section of this. So what is my the elevation? This will ensure we have so this will ensure that we have like a consistent level. So this will ensure that we have like a consistent okay, so you have marked all around. But now I'm actually rethinking everything like, what if I instead drill holes here that the exit air will maybe rush out through the body? I'm thinking maybe that would be better because we can easily maybe put a filter around. But now I'm rethinking everything like, what if I instead drill holes here that the exit air will maybe rush out? I don't know what decision to take here. Maybe that would be better because I could like drill multiple holes all around here, like the L exit through those holes. I could even maybe use a tube to now tap the air and then maybe send it to maybe cool the motor. That's a brilliant idea. But I don't know. Because I could even maybe use to like maybe the air is going to like just until there's no way we could maybe take that air and maybe do something else. Or you be complicated to maybe take the air and you have to go to create like a mountain like maybe of a mountain point because the drainage is a bit complex. But if you have holes, it's a bit more easy. But now, if you are creating holes, what we're actually doing is we are how would I say? We are increasing like it means the holes have to be at really close proximity. If not, what are we now? How would I say? Since we are narrowing the aperture or the path through which the air flows, we are somehow reducing the pressure since the air will have to travel faster. So the best way to optimize the suction force is to create the highest pressure at the output, and then so the input has the lowest pressure, or the pressure gradient is a bit higher. So if we're drilling holes, then you have to be very close, and that will reduce the structural integrity of this, and this plywood towel is not that strong. Let me see. But we could still cut this, and then if we had maybe filter, we could maybe just wrap like a wool or something around the perimeter of this. That would do. Yes, so we just take this because drilling holes is a bit complicated, and I don't like drilling plywood. Plywood is so fragile. So we just get a knife and carefully cut. Just hope I cut in the right point. I don't like drilling plywood is so fragile. Carefully cut. Let's do a time lapse. This is not too much time. Oh, no. Okay, so we are done cutting the other stuff. So air is going to be sucked in here, and then shot out or flunked out with the aid of this centrifugal, the fictitious force, yeah, but it's actually centrifugal force, centripetal force, yeah. Yeah, all those controversies is right. So you have an impeller. What am I doing? So yeah, I guess that's it. So you can see it's actually like, so those are enforceable, just like put the other screws that we didn't. So there, yeah, put everything in place. This screw is a bit too large. Something small. I'm not using any screw that can fit. I don't know. This one. So this crushed. So I can stop it. I'm not using any screw that can use it. I don't know. Yeah. This one. A little large, but it's crushed. So I can stop it. I'm not using any screw that can use it. I don't know. Yeah. This one. A little large, but so I want to actually test it, right? I want to see if it works. I'm afraid the shouldn't work out. Yeah, this aluminum. I want to actually test it, right? I want to see if it works. So everything is solid. This shouldn't work out. Yeah, this aluminum. So I want to actually test it. You have air coming in here and then flinging out this way. Everything is solid. Just tighten up everything. So you have air coming in here and then flinging out this way. Everything is solid. Okay, so we managed to hook up everything together. So let's just go test one. Yes, you can't run it for long because this is a universal motor and you have everything sealed up. We have even created holes for air to rush in to cool the motor. So I made this quick attachment so we could make use of the suction. Okay, so I made this since I don't have large enough to fit in here, and then we now have the suction. We can now use this to suck up dirt. Initially this actually meant to suck up water, right? So we have to do something like a trap container, right? But I haven't had time to make that. But I made a cyclone a while back ago. I doubt it will still work. So cyclone is simply used to trap dirt, right? It's kind of like what's used in industries, like those towers, right? It's used to it's commonly used to separate sawdust or filter sawdust. So what happens is we have the suction force here, right? So it sucks in air. So as a result, we have a pulling force from here. So when please put this close to the dirt comes in, or the dirt comes in with the air, right? Now since the dirt is usually more heat, right? It sticks to the wall, spirals around the wall, and then empties itself into this container. So they take it later on and throw it, and then the clean air then rushes here. So I need to create cut part of this tube, and then so I need to cut part of this tube and then attach it here so we could really suck up the dirt, right? So let's do that. I'll get my cutter. Okay. Okay, so I think this push is a bit like this, right? So let's see this. This will be okay. So Okay. Okay. Yeah. Oh, that's like. And then this hose then connects this. I have this like funny tubing that was insert here. Then it connects two tubes together. Right, something like that. This tubing hold up to the suction and out. Okay. So that's what we have. Okay, so there's some dirt in here, so I'll just empty it here, like some plastic shape with PVC shape. Um, so you see, oh, okay. So here we have our dust, like it's stick together. Oh god. Like, okay, so I'll just turn on the alarm if you want. Oh, so some got in here and then some got flung out. So let's see what we got. So we got some dirt there. So let's try that one more time again. At least the particles are now fine. That was a mess. So let's take a closer look. Okay, so we'll try one more time again. So let's turn it on. Like, what the? Oh, see. Let's see. Well, it's not bad. Not bad, but you have like, okay. Okay, so it's not the best filter because okay, so it's not the best filter because these things are a bit complex. So based on like the size, the angle of inclination of the cyclone, it determines like the type of particles you filter out. So that's why you often see they combine different sizes of cyclones in vacuum cleaners, right? At different levels. So maybe they begin by filtering the smaller particles, the bigger particles. Then we have other cyclones was filtering the smaller particles. Yes. So I think it's not bad. Yeah. I'm really impressed with the suction. I doubt if you do the same thing with water, but yeah, we don't really have that much water to suck, right? We're just like squeezing thin film of moisture or water from the floor and then sucking it up. But I think the suction is good for an unsealed system because like all this, the aren't even sealed. I just like inserted in here. You have like this tube is kind of like cracked. Here you have like holes. I just use this around to open this hole. So and even here you have like a crack. It's just yeah, it's not bad. Wait, should I try water? Maybe water might work. I don't know. Let's see. Okay, so after thinking for a while, I think let's try water. Okay, so I'll simply empty this plain water boy close to electricity. Just don't empty this somewhere. Okay. Dry container. It doesn't even need to be airtight this section. Okay. Ooh, fingers crossed that it works. I'm just using this pliers and this transformer since it's heavy to hold everything in place. Oh, just give me a hand, man. This will stick in place. Okay. Let's get the camera close. Okay. Better focus. Okay. So let's turn everything on and see. Disaster is about to. Afraid, man. Like. Usually suck up all the water. It works for water too. Like this could use like a cyclone to also suck up water. Wow. Okay, so I poured some water on the table right to see if it can, like maybe suck it up. So let's just try that and see. Okay, so I wouldn't surprise you some point, like if you have access to an impeller, you definitely have access to a vacuum cleaner's motor. Why don't you just use the whole thing instead of like mixing using a blender's motor? Well, initially I didn't have access to the vacuum cleaner impeller. In fact, I just found the impeller lying around. I happened to I really began designing my own. Like this was the first one I designed. If you take a closer look, you'll notice the blades. I don't know how they're called. Yeah. Really straight and it's actually small. The suction generated by this was really small, so I then moved on to this one. You can see it has a thinner profile and then the blades are a little bit more curved, and then I have to reinforce it with some the cables. Like I have to put it close to the plate and then glue it in place, and then I was trying to like add this strap so it sticks in from this inlet hole, right? So this one too, yeah, it was good, but it wasn't that great, so I had to upscale, increase the size. To this one, you can see I already marked the the blade profiles, right? So they were to follow this part, and then this was like the intake, right? So I was actually working on this when I found impeller, so I was like, why waste my time on this? But this is to show that you can actually definitely be on impeller. And the purpose of this video was like, what if I was stuck in an area, I had just a blender motor, could I and I wanted a vacuum cleaner, I needed a vacuum cleaner, could I build one from just the blender? Yes, the answer is yes. Yeah. So that's it. It's just like a challenge. It's not like something feasible because there are smaller pumps. There are like small suction pumps that could generate a good amount of thrust, that use brushless motors, use more efficient impeller designs. Like check, for example, what's in the Dyson right? Yeah, so that's the purpose of the video, is not to build something efficient, it's like more of like survival.